Good afternoon. Let's go back to substitution. Last time we were doing substitution related to trigonometric functions. Let's review the trigonometric derivative formulas again. Derivative of sine is cosine, and derivative of cosine is minus sine, and derivative of tangent is secant squared of x. Derivative of cotangent is minus cosecant squared of x. And derivative of secant is secant times tangent. And derivative of cosecant is minus cosecant x times cotangent of x. We worked out some problems. We will go back to the problems. The next problem is integration. 40x cubed times secant to the 7th power 2x to the 4th power times tangent of 2x to the 4th power dx. Three functions are multiplied, and we are using substitution. So the best candidate will be either secant or tangent. If you differentiate tangent by putting u equals tangent, then you will end up getting secant squared. And we have secant 5th power because it should be secant to the 7th power altogether. So we cannot handle secant to the 5th power. So we will think about putting u equals secant. And then what will happen will be du. When you differentiate, that'll be secant 2x to the 4th power times tangent 2x to the 4th power times the derivative of the inner function, which is 8x cubed dx. Still, what is happening here is when you multiply u and du, we have only secant to the 2nd power. So what we have to do will be, we will break this one into secant to the 5th power 2x to the fourth power times 6 power. And secant of 2x to the fourth power. And then when we differentiate secant, we will get secant times tangent, right? So U substitution will make sense. So let me rewrite the function again. Then I would write like secant to the sixth power 2x to the fourth power times secant of 2x to the fourth power. And then we have tangent of 2x to the fourth power times, we had this one, 40x cubed dx. So what we want to do is we want to rewrite it as integration secant 6 power 2x to the fourth power times secant times 2x to the fourth power times tangent of 2x to the fourth power times derivative of that is 8x cubed, and then the x. The difference between this one and this one is 5, right? 40 is 8 times 5, right? And 8 is here and 5 is missing. So I would write 5 in front of integration. So those two are the same. 5 times 8 is 80. But the way I reorganized is consistent with this part. This one is du. And what is this? This one is u to the sixth power. So by using substitution, that could be converted into the power functions integration. So that is 5 times integration u to the sixth power du. So that is 5 times u to the seventh power over 7 plus c. And then that is 5 over 7 u to the seventh power plus c. And then that is 5 over 7 times u to the seventh power is secant to the seventh power 2 x to the fourth power plus c. Do you have any question? Indeed, this is 4. And the next problem is integration 9x squared minus 9 times secant squared of x cubed minus 3x dx. What you know is if you differentiate tangent, then you will get secant squared. When you integrate secant squared, you will get tangent. But the problem is secant function is a composite function. So we have to think about what the derivative of the inner function is. So if we put the inner function as x cubed minus 3x, then its derivative is 3x squared minus 3 and dx. So what we are thinking about is we replace x cubed minus 3x by u. And then what is this? This one is, I just want to keep this expression. So I would write 3x squared minus 3 dx. And if we multiply by 3, then I can make the original one, right? I can take out 3 there. I shouldn't copy dx here. But we have to combine these two. So what we want to do is we want to write this integral by writing 3 first, 3 integration secant squared of x cubed minus 3x times 3x squared minus 3 dx. So what can you do? So this is 3 integration. We have secant squared of this time u times this time is du. So 3x squared minus 3 dx is du. So this is just the same pattern with the formula, straightforward formula. So we have 3 times tangent of u plus c. And then we can write as 3 times tangent of u is x cubed minus 3 plus c. Any question? The next one is integrals involving exponential and logarithmic functions. Before we do it, we will think about the integration formula related to exponential and logarithmic function. If we integrate e to the x, then you will get e to the x. And if you integrate 1 over x dx, then that is natural log of absolute value of x plus c. And if we integrate b to the x dx, then that will become b to the x over natural log of absolute value of b plus c. And then if we integrate natural log of x dx, that is x times natural log of x minus x plus c. So you have to remember all of them very clearly. The first question is integration. 3 times e to the 2 over x cubed over x to the 4th power dx. This is a fraction of functions. So what we want to do is we want to regard fraction as multiplication of two functions like this. And then we can see which part is the derivative of what. In the denominator, we have x to the 4th power. In the numerator, we have e to the fraction power. What you can see is this degree is 1 more than this one. And x cubed is in the denominator. So if you differentiate that, then it would be something to do with 1 over x to the 4th power, right? So what I will do will be, I will regard this one as u. I would write u equals 2 over x cubed, then it'll be 2 times x to the minus 3 power. And when we differentiate, that'll be 2 times minus 3 x to the minus 4 power, which is minus 6 over x to the 4th power dx. I dropped the x here. So just numbers are different. So what I want to do is I want to get rid of this. So I can write it as negative 1 over 6 du equals 1 over x to the 4th power dx. So this integration can be written as 3 times integration e to the 2 over x cubed over x to the 4th power dx. And then this one will be 3 times integration e to the, this power is u, and remaining part was 1 over x to the 4th power dx like this. And so I would write minus 1 over 6 du. Any question? So we have 3 over minus 6 integration e to the u du. So that's minus 1 over 2 e to the u plus c. So that is minus 1 over 2 e to the u is 2 over x cubed plus c. Do you have any question? The next problem is integration 2 over x minus 6 dx. Firstly, I want to make sure that nobody would write this one like 1 over x minus 1 over 6. That is wrong. So the integral formula we know is integration 1 over x dx equals natural log of absolute value of x plus c. We have only one term in the denominator. It has two terms. So what we want to do is we want to put this one as u. Moreover, the denominator, derivative of denominator is just the dx because that's degree 1. So I would put u equals x minus 6, then du equals dx. And then this integration will be rewritten as 2 times integration 1 over u du, right? And then that is 2 times natural log of absolute value of u plus c, which is 2 times natural log of absolute value of x minus 6 plus c. Any question? The next problem is integration 2x over x plus 8 dx. The difference between the previous question and the current question is the degree of the numerator. In this case, there is no x on the numerator. And so we can easily say that the derivative of x minus 6 is just dx. So we can do substitution like this. The problem with the next one is the degree of the numerator is also 1, the same degree. And we cannot split this fraction. So what we will do will be we will still put u equals x plus 8. And then we will get du equals dx. But because of this redundant x, what we will do will be we will solve for x. Then that'll be just a u-related expression. X equals u minus 8. Why do we do that? Because we instead of two terms in the denominator, we make the denominator as one term. And then by solving for x, we can make the numerator into two terms. So the point is a over b plus c is not equal to a over b plus a over c. But what we know is if we have a plus b over c, then we can split that out and then we can do term by term integration. So that's the idea. So the integration can be rewritten as 2 times x over x plus 8 dx. So that is 2 times integration. X can be written as u minus 8 over x plus 8 is u, and dx equals du. So that is 2 times integration. Let me write down u over u minus 8 over u du. So that is 2 times integration 1 du minus integration 8 over u du. Right? And then term by term integration, 2 times 1 du. This part is u, right? So that is, so 2 open parentheses u minus 8 times the second one is natural log of absolute value of u plus c. Do you have any question? The remaining step is just the substitution. I would expand this out, then that is 2 times u is x plus 8 minus 16. Natural log of u is x plus 8 plus c. Any question? The next problem is integration. Natural log of 2x over 9x dx. We can rewrite it as integration 1 over natural log of 2x times 1 over x dx, but 9 is multiplied here, so 1 over 9 will be written in front of integration. Then what you know is integration. When you think about derivative of natural log of x, that is 1 over x, right? But unfortunately, it is not x, it is 2 times x. But it's not a big deal because we can write u equals 2x. Then du equals 2 dx. So dx equals 1 over 2 du. So that is 1 over 9 integration. Natural log of 2x is u times, I have to write down, yeah, so yeah, 1 over 2, yeah, so 1 over, this one is d u, but we have to write 1 over 2 here, right? Any question? So actually, did you notice something? Yeah. Yeah, 1 over x. And so we have to put u equals natural log, right? Yeah. Yeah, I wrote here, and then instead of discussing the chain rule, I just put u equals to x. Right. So u equals natural log of 2x. Then du equals 1 over 2x times 2 dx. So derivative of logarithmic function times the derivative of the inner function. So here is u. And then we have du equals 1 over x dx. So actually this one is du, right? Any question or confusion? Did everybody follow? Right, so let me write it down again. 1 over 9 integration u du. So it became just a simplest form of the function. And then the integration is u squared over 2 plus c. So that is 1 over 18. U is what? Natural log of 2x squared plus c. Do you have any question? The next one is integration 2 times log base 5 of x dx. In this case, the log base 5 is the problem, but in college algebra, you learned the change of base formula. So that is natural log of x over natural log of 5. And then the denominator is just a number. So we will rewrite it as 2 times integration natural log of x over natural log of 5 dx. So that is 2 over natural log of 5 integration natural log of x dx. So we even don't need a substitution. It's just purely about a change of base formula related problem. So we learned the integral formula for this one, that is x natural log of x minus x plus c. Any question? You can ask me any question if something is not clear. The next question is integration 8 to the minus 5x dx. The formula you learned about this type of integration is integration a to the x dx is a to the x over natural log of a plus c. We have a power x, but we have minus 5x. So we will put u equals minus 5x. This one becomes u. And then du equals minus 5 dx. We have only dx here, so we will solve for dx. Then we have minus 1 over 5 du. So we rewrite the integration like a to the u and dx is minus 1 over 5 du. So that is minus 1 over 5 integration a to the u power du. So that's minus 1 over 5. We just use this formula, then times a to the minus 5x over natural log of 8 plus c. Yeah.
It's a pretty good question, but you can't integrate when you have a negative x, or does can we be able to just use the like the starting gauge for the minus 5x and just integrate into the formula, right?
I don't get the point of your question.
So for the base problem, 8 to the negative 5x,
Mhm. Yeah.
why can't you just integrate off that? Why do you do so?
That's because that's not like formula. In the formula, this is x, right? Not minus 5x. And so what I'm saying is you cannot rewrite like this is not like a to the minus 5, a to the x. If we can do that, then we can take this out and just so we use formula, but that doesn't go well, right? Do you have any other question? Okay, that's about integral related to exponential and logarithmic function. The next one, we have a lot of formula which may be confusing, but definitely at least until the end of this semester, you have to remember all those formula as it is. So this is about the integration related to inverse trigonometric function. Integration 1 over u square root of u squared minus a squared du. So something is multiplied outside, and then that is secant 1 over a secant inverse of u over a plus c. What is important? Both are just purely squared. Both are squared. There is no number in front of the variable. Integration 1 over a squared plus u squared du. That is 1 over a tangent inverse of u over a plus c. The next one is integration 1 over square root of a squared minus u squared du. And then that is sine inverse of u over a plus c. The fundamental form of derivative goes like this. Inverse tangent function's derivative is 1 over 1 plus x squared. And derivative of inverse sine function is 1 over square root of 1 minus x squared. And the derivative of secant inverse of x is 1 over x square root of x squared minus 1. Make sure that you are not confused with the formulas, both integral and derivative formulas. So if you go to the course website, then you can see the lecture note. I'm giving a lecture. So just if you want, then you can take a picture, but just you can find the better one. So we have integration 1 over x times square root of 4x squared minus 4 dx. It looks quite complicated, but where is the formula I wrote? Let me just write down again. The variable is multiplied outside of the square root in the denominator. So that's something to do with inverse secant. What I wrote was integration 1 over u times square root of u squared minus a squared du is 1 over a secant inverse of u over a plus c. So what we want to think about we want to compare the patterns. What I told you was that there is no number in front of this variable, or even if variable is involved, the whole thing must be written as this one must be something squared. Of course, that is 2x squared, but in this case, we have here 4 and 4 the same number, so it is better to take those out. Then things will be easier. But you can just write down as 2x squared and then proceed the calculation. But I will take out 4 here. Square root of 4x squared minus 4 is square root of 4 times open parenthesis x squared minus 1. So that is square root of 4, which is 2 times square root of x squared minus 1. So that's exactly this pattern. Let me write down again. This part is 2 square root of x squared minus 1. I would write the number in front of integration. 1 over 2 integration 1 over x times square root of x squared minus 1 dx. So what is that? That is 1 over 2. And then this number 1 is 1 squared. So a is 1. So we can ignore this part and no denominator. So secant inverse of variable is x plus c. The next question is also pretty similar. Integration 1 over 3 plus 3x squared dx. Both numbers are the same, so I will take that out. And then that'll be 1/3. And then I would write down 1 over 1 plus x squared dx. And then we have integration 1 over a squared plus u squared du. This one is 1 over a tangent inverse of u over a plus c, right? By the formula. This time a is 1. So we end up getting 1 over 3 tangent inverse of x plus c. Any question? The next one is integration 1 over square root of 25 minus 25 x squared dx. So nothing appears in front of square root and number squared minus x squared. So that's sine inverse 1. So the formula was integration square root of a squared minus u squared du equals sine inverse of u over a plus c. So we have integration. What is this? This one is square root of 25 open parenthesis 1 minus x squared. So that's 5 square root of 1 minus x squared. So in the denominator, we have 5. So we will write as 1 over square root of 5, 1 over 5. And then 1 over square root of 1 minus x squared dx. So that's just a formula. So that's 1 over 5. A is 1. So we have sine inverse of u over a. U over a, which is x in this case, plus c. Any question? So as you can see, if you see the formula, both secant inverse and tangent inverse, there is 1 over a, but sine, there is no 1 over a here, right? So it's quite confusing, but you have to be clear about how things are going. The next one is about just substitution. We have tangent inverse of x over 1 plus x squared dx. We want to regard this one as the multiplication of two functions. And we want to think about what the relation between what's on the numerator and denominator is. Before we do that, we recall tangent inverse, derivative of tangent inverse, then that is 1 over 1 plus x squared. What's in the denominator? So we regard that as tangent inverse of x times 1 over 1 plus x squared dx. And so the natural decision to make is we will make u equals tangent inverse of x. Then du equals 1 plus 1 plus 1 over 1 plus x squared dx. So what is that? That is integration u d u, right? This part is du, right? So we can fix it to the just power function, simplest form. So that is u squared over 2 plus c. So u squared is tangent inverse of x squared over 2 plus c. The next one is integration sine inverse of 4x over square root of 1 minus 16x squared dx. So we regard this one as integration. Sine inverse of 4x over square root of 1, I'm copying the same, integration sine inverse of 4x times 1 over square root of 1 minus 16x squared dx. Why am I doing so? Because I want to regard one of them as a derivative of the other one. Obviously, we have to put u equals sine inverse of 4x. Then du equals 1 over square root of 1 minus 4x squared times what is the chain rule? Chain rule, when we apply, we have 4 dx, or we have to think about this one. Yeah, so for this part is 1/4 du, and this part is u, right? And then the integration is u times 1/4 du. So it is converted to the same pattern. So we have 1/4 u squared over 2 plus c. So that is u squared over 8 plus c. So that is u, which is sine inverse of 4x, that's squared, over 8 plus c. Do you have any question? Yeah.
So like, let's say for like a test that like, um, I feel like 1/4 times that over 2 plus c, would that still be right? Like if it was a different form of it, or does it have to simplify all the way?
Well, the final answer must be exactly like this. Okay. It cannot be anything else. For this particular case. Do you have any other question? The next one is integration secant inverse of 3x over x times square root of 9x squared minus 1 dx. For our convenience, I will just write it again, like secant inverse of 3x times 1 over x square root of 9x squared minus 1 dx. If you remember the formula correctly, then definitely you should be able to see the second factor is the derivative of the first one up to constant. So what we want to do is we want to put u equals secant inverse. So u equals secant inverse of 3x, then du equals what? That is 1 over 3x times integration 3x squared minus 1. And then we have to apply the chain rule. So 3 dx inner function. So these two will cancel each other. And we can say that du equals dx over x over square root of 9x squared minus 1. Right? So indeed, the second part is du, not just opt constant. So we can rewrite the function as integration u du, and then that is u squared over 2 plus c. And u is secant inverse of 3x squared over 2 plus c. Do you have any question? No question? Do you have any question about next week's quiz? Yeah. Default range, quiz range for each week will be the materials I cover in the previous week. You will take a quiz every Wednesday, but so Monday's material will not be on the quiz. For next week's quiz, definitely I would try to see whether you have clear memory with many formulas. So yeah, so if you're confused with formulas, then you will have a lot of problem. So I will clarify a little bit more. So I will make the quiz problems first, and then I will give you further instruction. But definitely the most important part is going through all the formulas, yeah, on the first week's material and what I wrote on the first week's academic activity. Okay. And in other class, someone asked me what will be the pattern of the questions. So in our class, many quiz questions, maybe majority of quiz questions will be multiple choice over free response question, even if the exam will be combination of free response and multiple choice question. One of the reason is if I compose just a free response question, then I have to make multiple pages quiz question. I have to use multiple pages because I have to give you more space to write all things down. And if I give you several problems with free response question, then just it'll be too long to both you and me. But it doesn't mean that so there I will end up giving you like at most 2 free response question. So but I do believe I have to ask more questions, and so I will compose most likely to compose multiple choice questions, but that will require you to go through the process, and I will ask you about the aspect of questions as well as the final answer with multiple choice format. Okay. So 2.1 is about area between curves. Last semester, you learned about integration. We have y equals f of x. We want to think about the area under the curve from A to B. After you learned integration, you learned if f is greater than 0 and continuous, then integration a to b f of x dx, that integration is area under the curve. What we want to think about in this section is about area between curves. So area under the curve means we want to think about this function, which is located above x-axis. And what we did was we just drew rectangles and thought about each rectangle's area, and we refined those rectangle so that it becomes thinner and thinner and almost like just a vertical stick. And then when we add them up, it'll get closer and closer to the area of under the curve. So when we did it, we used the x-axis, but this time we want to think about the area between curves. So we want to regard this x-axis as one particular type of function, y equals 0. So in other words, we can say that this one is area between y equals f of x and two function y equals 0, which is x-axis. How about the area between two curves? So instead of x-axis, we want to think about two functions. This one is y equals f of x, and the other one is g of x. Here is A, and here is B. When we think about the area between two curves, we will do essentially the same thing, but instead of x-axis, we will use g of x. Like this, and we think about the area of the rectangle. So the difference between x values is denoted as delta x, and the length of dotted line is f of xi star minus g of xi star. So we are using this x value denoted as xi star. Do you have any question? So area is limit n goes to infinity, summation I equals 1 to n, f of xi star minus g of xi star times delta x. So what I told you was this one is the height of rectangle. And this one is width of the rectangle. And so this is the area of rectangle. And then what is n? N is the number of rectangle. So we want to increase the number of rectangle forever to make the added area of the rectangle close to the area between curves. So n goes to infinity becomes rectangles become thinner and thinner, so rectangles become slim. When this is the situation, what we can say is limit and summation is converted to the stretched as sum, which we called integration. And we wrote the lower bound and upper bound. And then f of x minus g of x, and then dx. As in calculus 1, when we consider the area under the curve, this time the x-axis became g of x and became area between curves. If f of x is greater than g of x for x in A to B. Any question? Find the area of a region between two functions. R is the region bounded above by f of x equals minus 5x over 4 plus 5. And below by g of x equals minus 2x plus 4 over minus 1 and 5. Did I give you this? No, right? So both functions are linear function. And the region we are thinking about is the region f is bounded above and g is bounded below the lower bound. Yeah. Hmm? Yeah. The first one. Yeah.
But, um, I think that's the bottom of the area that you guys.
Well, yeah, so that's a good question. I will talk about that. Okay. When we think about the absolute value of this and this, one of them is 5/4 and the other one is 2. This one is larger, right? And that means this one is steeper. So in this case, there is minus, so it drops faster. That's what we have to remember. So what you have to think about is we have to think about two possibilities. One drops faster and the other one goes slower. So this one is obviously y equals f of x, and this one is y equals g of x. And then here is minus 1. Here is 5. In this case, what's happening here is in this region, this intersection point is happening between minus 1 and 5. And so to solve this problem, what we have to think about is we have to think about this region, right? Because f must be bound the upper bound, right? After it passes here, f becomes smaller compared to g of x. Another possibility is something like this. It's not that easy to draw. Yeah, so it's like this. This one is y equals f of x, and this one is y equals g of x. So in this case, intersection point is outside of -1 and 5. And in the region -1 to 5, f is always larger than g of x, right? And just those are the possibility for this problem. So what we have to do first will be finding the intersection point to make sure that intersection point doesn't occur between -5 and -1 and 5. Let's solve the equation. At the intersection point, x values will be the same. So we multiply by 4 on both sides, then we get -5x plus 20 equals -8x plus 16. And we add 8 on both sides. Then we have 3x, and we subtract 20 on both sides. Then we have -4. So we have x equals -4/3, right? So that means this one is the case. So we just integrate from -1 to 5 because f will be always larger in that region. So we have integration -1 to 5 f of x minus g of x dx. Then that will be integration -1 to 5. F of x is given as -5x over 4 plus 5 minus g of x is -2x plus 4 dx. We want to gather the like term. And this one is 8 over 4. Integration -1 to 5. Minus 5x over 4. Minus will make plus 8 over 4x plus 5 minus 4 dx. So that is integration -1 to 5, 3 over 4 x plus 1 dx. And then we will do term by term differentiation. So it'll be 3 over 4 x squared over 2 plus x from -1 to 5. And then what is this? This one? Yeah. And so that'll be 3 over 8 x squared. We have to evaluate for the upper bound. So that is 5 squared minus 1 squared. Plus for the second term, upper bound is 5 minus what? -1, right? So that becomes 3 over 8 times what is this 24, right? 24. Any question? This one is just 1, so 25 minus 1, right? Plus this one will be 6. This is 3. So 9 plus 6 equals 15. Do you have any question? Yeah.
Go back to the other page.
The other
You
page?
got the 3/8.
I got 3/8 from here.
How do you get into 3/4 from that equation?
3/4 is coming from here. Am I answering your question?
How did you get from the top equation to that?
From here to here?
Yeah.
Here to here? Okay. And so that is negative 5/4 plus 8/4 x, right?
Yeah.
Yeah, the denominators are the same, so we just do operation with the numerator.
Yeah, that makes.
Yeah. Any other question? In the morning class, I stopped here. I spent more time, but I don't like to go further because I will be confused about where I stop. And I want to get more question if you have, and you can approach me and ask me question and clarify anything which was unclear. Yeah.
So on the top equation where you add the two fractions,
At-
8/4 is attached to the x. Would it not? Would you still be able to add those two fractions?
For this one,
No, below it.
below,
So 8/4 is the coefficient for x.
yeah.
So how would you be able to add those two?
Yeah, so let me clarify a little bit more. So I think the probably what you're saying is minus 5/4 times x is the same expression.
Oh, I didn't see the x.
Yeah, here.
Thank you. Can I see the last page?
Last page, yeah. Here. Is something unclear? Yeah, I thought what may confuse some of you, maybe minus 1 squared looks like plus 1. It is minus 1. So in this case, this one must be done first. Rather than it goes like minus becomes plus.
Okay, I get it.
Okay. Any other question? I will send out an announcement, but this weekend, one of the important thing you want to do will be downloading 3 AIs on your phone for further practice later point to prepare for the free response question better. As I said, you will take a picture of your actual answer and solution, and then you will ask AI to grade it, and then it'll give you a lot better than better response than you can imagine now. So no matter how you're writing, that'll give you a very reasonable response about how things are going and how that will be graded. But I'm not saying that the rubric it is providing will be identical to the rubric we will make, but at least you will get some idea about how many points you will get approximately. So what and also just AI will be quite helpful, but that's the dominant reason I'm asking you to download AI, ChatGPT, Copilot, and Gemini on your phone this weekend. Yeah.
Oh, nothing, never mind, sorry.
Okay. Do you have any question?
Yeah.
Yeah, I could have. So I thought probably some of you will leave, but everybody is just sitting. So I thought something is strange. Okay, so do you have any other? Yeah. So what assignment? What homework? Yeah, homework, Newton Alta. Yeah, Newton Alta. If you go to the assignment page, and then you can see the first assignment. That is due next Wednesday, but I heard the first week's assignment will be a lot more than any other average week. So you have to you will have to try to finish by this Sunday. And then if you need more time, then you can spend a little more time. Yeah. The first one? Yeah, just a moment. Let me stop recording.